This video tutorial is a walkthrough for heat exercise part 4 for GPH 301 Intro to Quantitative Geography. Heat exercise part 4 is its own separate quiz online, and it's the last bit for the heat exercises. So as always, I just want to remind you that the assignment is online in Canvas. The PDF document, it's the same one we've been using, but it contains the context and background for the topic that we're looking at here. And then the Excel workbook, of course, contains the data that you'll need. Of course, you can continue working with the one you've been working with. So this week, what we're looking at are two concepts. We're looking at the concept of excess, death, or mortality, and the value of a statistical life. And they're relatively simple concepts, but they're important because they're used by policymakers to prioritize when things go bad, about identifying what people are willing to commit to deal with a problem that's causing illness or death or destruction, for that matter. And so the assignment instructions contain examples and some context so you can understand how these concepts are applied. But I want to use a more contemporary example that at this moment in late April 2020 is on probably the top of all our minds, and that's the COVID-19 pandemic. COVID-19, as you probably know, is the name of the coronavirus that is currently causing a pandemic. Since we have no medicines that are effective at the moment and we don't have vaccines yet, we're all forced to shelter in place to avoid contact and possibly spreading or contracting the disease. So the concept of excess mortality and the value of a statistical life are particularly apt for this situation because these are the things that people are thinking about and the way that they're talking about these issues and thinking about how to allocate resources. So the Centers for Disease Control is a primary federal agency in the U.S. Charged with tracking vital statistics of the nation. That is to say, statistics about births, deaths, and illnesses. And they do that because they're a lead public health agency. And as a public health agency, their mission is rather to protect the public's health. And the way that they do that is by closely monitoring what's going on. And they do that by collecting statistics or data about deaths and illnesses from around the country, all of which are submitted by state agencies. And what they're looking for when they collect this data is for things that look unusual. And so that question of what qualifies as unusual is important because it defines when we need to jump into action or when we think there's a problem happening. And if you've been following the news, the COVID-19 pandemic, we believe at the moment, started somewhere in China and then spread. And we started hearing about it in China in December, January, something like that. And as it turns out, it was already spreading beyond China by that point, but we didn't know that. And no one knew really how to track it because we didn't know what it was. It's a new kind of virus. It's a new disease. But in retrospect, what we see is that it has a lot of similarities to the flu, even though it's not the flu. And that's how researchers are starting to understand when it erupted and how it spread and where it probably is, because we're still at this point behind in terms of tracking it or understanding how to identify it quickly. So the precise numbers on who has contracted COVID-19 or who's died from it are fuzzy at best because we're still it's still being worked out. In any case, because of its similarity to the flu and pneumonia, that's what researchers have been focusing on. So the graph that we're looking at here is showing a comparison of what typically happens with deaths from pneumonia and the flu, COVID-like deaths, and what we've seen recently. So the way you look at the graph is the bottom axis is the number of weeks in a year. So you see this 2018, 19, and then 20. So this is tracked by week. And then the vertical axis, the y-axis over here, shows the percentage of deaths that are due to, again, pneumonia, the flu, or COVID, again, because of their similarities in symptoms. And so the lower black line of this graph shows you what typically happens in terms of the percentage of deaths from those type of diseases, from pneumonia and the flu, let's say. So typically, anywhere between 6 and maybe say 7% of all deaths are due to the flu and pneumonia. And that's usually around amongst the older people, people who are immunocompromised, have problems with their immune system. And that's to be expected, unfortunately, and it's fairly predictable and it's kind of stable. And so we look at that and we see the seasonality play out so that they're highest in the winter and they tend to drop off by the summer, in the spring. So that's what we expect. The red line is the actual percentages over the last number of weeks. And what we see is that red line has initially followed the expected number of deaths. And then in February of 2020, we begin to see in the US this massive increase in the number of deaths from things that are pneumonia and flu-like, which we now are pretty sure were COVID-19 caused deaths. And so what we're paying attention here is obviously, one, the fact that line just jumped up, which is in itself scary. And as you can, if you look at the graph closely, it crosses the second black line, which is what they quote unquote call the epidemic threshold. But for our purposes, what's important is that the excess mortality is the idea that you have some number of deaths that are way above what's normal. And so the difference between the normal, which you would have expected people to die anyways, and the extra numbers up here, that's the excess mortality or excess death. And we use the term excess very deliberately because it tells you that this goes beyond what should be expected and what should happen. And so there's kind of a moral component to it because it's saying to us that humans have agency in this, that if we do something, we can change this outcome. And so excess death and mortality is both a quantitative concept in terms of identifying something that is above a threshold, but it's also a moral concept because it's saying, you know, these are things that are preventable, and so that we should be able to intervene on. So that's excess mortality, you know, and as a concept. And quantitatively, again, it's very simple. You take the expected number and subtract the difference from the actual number that happened, and that's the excess, right? Okay. The second concept that's related to this is what's called the value of a statistical life. So we know this is happening. It's massively disruptive. We're trying to figure out what to do. Now the question is, what are we willing to do, right? I mean, at the end of the day, we are interested in not getting sick and not dying from this. But from a policymaker's perspective, we're talking about Congress, let's say, we're trying to decide, you know, how much of our resources as a nation should we devote to this? But you can think of this at an individual level too. So my question to you would be, or is, how much are you individually willing to pay to reduce the risk of illness or death from this virus? So you might say, oh, I'll pay anything. But that's not really true, right? Because you still have to go on after this too. And besides, you're not infinitely wealthy, right? You have limited resources. So you can only pay what you have, right? So you're limited by not just your willingness to pay, but your ability to pay. So let's say that you're willing to stay at home for 3 months without working, right? Which a lot of us might find ourselves doing anyways. Now that's significant, right? Because if that means that you're not going to work and you're not going to get paid, then you're paying for it. Let's say in your case that you work 20 hours a week on average, right? So I'm making up numbers. You're part-time and you're making $15 an hour. And so if you stop working and you don't get paid for 3 months, that's 12 weeks. So we take your hourly rate, multiply it by the number of hours per week, and then by the number of weeks, and we say, so that's $3,600. So if you stay home for 3 months without working and you were working part-time at that rate, then you're losing or paying, however you want to look at it, $3,600. So we would say that's the value of a statistical life, right? So that's how much you'd be willing to pay to save your life, right? And again, the concept here is not that you don't have infinite resources. You're saying, here's what you're able to do, right? So that's what the value of statistical life is. So, but if we take that number, right, and we say, okay, let's imagine that we adopted that number, $3,600, and we applied it to every worker in America, right? This is what we call a cumulative VSL, so a cumulative value of statistical life. So we're taking all of that individual amount you're willing to pay and multiplying it times the number of people that it applies to. So if 130 million workers, which there are in the U.S., if all of them are willing to pay $3,600 to avoid getting sick or ill, then we say the cumulative VSL is $468 billion, which is a huge number, right? And what that means is that that's one measure of what the country might be willing to pay to deal with this problem, right? If assuming that we were willing to sacrifice $3,600 per person. If we applied it to everybody in America, and there's 328 million of us at least in the U.S., then that $3,600 per person comes out to be $1.2 trillion for the country, right? And you see the number in parentheses is that number written out, what the real number would be. That's a huge number, right? That's basically a 1 followed by 12 zeros. And it does seem big, but actually this is not too far off from what the government's already done. So you may have heard in the news about the stimulus checks going out. Hopefully you're probably going to get one too. And those come out of a law that Congress passed called the Coronavirus Aid, Relief, and Economic Security, or CARES Act. And it was the bill that basically spent $2 trillion to try to help people across the country deal with this pandemic, right? Because of the disruption of business and work. And so about half of it is for the stimulus checks that you are getting individually. And if you have kids, you can be up to $500 a kid. And then about a quarter of it's going to businesses, and then other parts for unemployment. And then you can see all the other sectors. So again, $2 trillion. So it's not too far out. I mean, there's a big gap there, but that's how much money the government allocated, right, to deal with this pandemic. So let's look at that number and say, what does that say about what the government thinks the value of a statistical life is? So in this sense, what we're saying is, what is the federal government willing to pay to reduce the risk of illness or death from COVID-19? So if we take that $2 trillion that in the stimulus package, we can look at it in the reverse of what we did previously. So $2 trillion divided by, if we just look at workers, by 130 million workers, that means that the VSL that's implied by this bill is $15,384 per worker on average. So that would be the value of a statistical life, which is more than you were willing to pay, right? Or could pay. If we take into account everyone in America, though, 328 million people, it goes down because it's being divided for more people. So then it comes down to about $6,000 per person. So we'd say then that the government's $2 trillion stimulus package comes down to, or equates to, a value of statistical life of about $6,000, which is what essentially in a way saying this is how much we're willing to spend to save a life, $6,000. I don't know if that sounds high or low to you, but we're going to compare it to other estimates that are actually already in law that are used when federal agencies are making decisions about how to allocate resources. And we'll do that next in the next video.